Well, this is BNU 2019 semester 2 assignment number 2. Okay, there are some important information here which I will skip, and then I know you're gonna read it, and I'm gonna move straight forward to the questions. Like in this page, this question 1 and question 2 that says question 1 says write 3/4/7 as an improper fraction, and question 2 says like 100/7 as a mixed fraction. Now let's first talk about the two of them separately. Okay, what is an improper fraction then? An improper fraction is when a fraction when the numerator is bigger than the numerator. Okay, something like 100/7. Okay, in question 2. Okay, um, like here 100/7 is an improper fraction because the numerator is greater than the denominator. Okay, so if I need to write a mixed, this is called a mixed fraction, okay, where we have like a 3 is the integer, and then 4/7 is the fractional part. Okay, so that's why they call it mixed fraction or mixed number. We have an integer and then also the fractional part. Now, if we need to convert a mixed number as an improper fraction, this is what we do. Okay, the mixed number will be like a and then b over c. Okay, to write it as an improper fraction, we do a times c plus b all over c. Okay, so in this situation, we're going to write, we're gonna do 3. Okay, so I'm gonna say we have like 3/4/7. This will be like 3 times. We're gonna do a is like 3, so we have like this is a, okay, and then this is b, and that is c. Okay, so this will be like 3 times 7, okay, plus 4 all over 7, and then 3 times 7 is 21. 21 plus 4 is 25, so that makes 25/7. This is the mixed number of the improper fraction 3/4/7. Okay, now in the following question 2, we have now an improper fraction. Okay, and then we need to convert the mixed number so to something that looks like this. All right. Before I do, I will say that we need to understand A, B, C here. A is the quotient. Okay, this A here is the quotient of the fraction. Okay, so this stands for the quotient of the fraction. The quotient is the result of division. Okay, and then this B here will be the remainder. Okay, the remainder will be at the denominator, remainder. Okay, and then C is the dividend. So I cannot write dividend here, but you know it's a dividend. Now, over here we're gonna say, okay, how many times 7 gets into 100? Because we do have like 100/7. We ask ourselves how many times 7 gets into 100. Okay, if we count in 7, for instance, I know 70 is 10 times. Okay, if I add and also 35 is 7 times 5, but if I do 70 plus 35, it's 105. It's more than that. So I can go a little bit I can take out 7 from 105. This is how I do calculation fast. Okay, let's see. I know that 10 times it's gonna be 70. Okay, 10 times. Okay, and then also 7 5 times is gonna be 35. Okay, that's 5 times. So meaning, okay, if I do the addition here, it's gonna be 105. But it's more, 105 is more than 100. So it cannot be 15 times. So 7 cannot get into 115 times. So it must be a little bit lesser than that. Okay. If this calculation is not really it's going to be like 1 unit lesser than that. So I need to minus 7 one time. Okay, I need to minus 7 one time. And then this will be 90, excuse me, 98. 98 is lesser than 100. Okay, it's very close to 100. So in other words, if because I minus one times, it's going to be like 10, 15, 14 times. Or you can just count in 7, okay? You know, up to 70 is only 10 times. So 77, 11 times. 84, 12 times. 91, 13 times. 98, 14 times. So we can stop there. We say, oh, 14 times. So 14 is the quotient. So it's what I'm going to write next to here, next to the fraction, the integer part. So this is going to be 14. I write 14 there. Now, because I have 98, meaning how much left, the remainder, okay? The remainder is 2. 98 to 100 is 2. So 2 is left over. The leftover is 2. 2 over what? Over 7. Okay? This is how we can write 100 over 7 in mixed number form. Okay? Let me start over. I said 7 gets you to 100. How many times? 14 times. How do I know it's 14? I count in 7. I already know that 7 times 10 is 70. So I can continue from there. 77 is going to be 11 times. Okay, maybe I should write. Hold on. I already know that by 10 here, okay, 1, 2, dot, 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 dot. By 10, it's 70. So by 11, it's going to be 77. By 12, it's going to be 84. By 13, it's going to be 91. By 14, it's going to be 98. Okay, so I cannot continue because if I say 15, I add 7 again because over here we add 7 all the time. Okay, we add, we plus 7, we plus 7, we plus 7, we plus 7 again. So if I plus another 7, I will reach 105, which is beyond more than 100. Okay, so I cannot add this. I cannot add this part here. So I stop by 14. So I say, therefore, okay, the quotient will be 14 here. Now, if I have 98, how can I get 98 to 100? The remainder is 2. Okay, so 2 will be the B. As I said, B has the remainder, and then this is C, the dividend. So that will be 14 2 over 7. Okay, thank you. Well, this is page number 2 of this assignment, BNU1501, semester 2019, semester 2, assignment number 2, page 2 also. So many twos. Okay, now in this page, most of the questions here is about the LCM, okay? LCM, which is the lowest common multiple. Now, let's start with, before we start with the questions, let me first discuss a little bit about the LCM, okay? I want to take like an example. Let's take an example like I want to find the LCM of two numbers like 2 and 3, okay? So let's first talk about the multiple of 2. Multiple of 2 will be like 2 because 2 gets into 2 once, 4 because I know remainder, and then 4 because 2 gets into 4 twice, and there's no remainder. 6, okay, 8, 10, 12. We can list as many as possible, okay, as many as we want, etc. Those are the multiple of 2. And then the multiple of 3 will be like 3, 6, 9, 12, 15, 18, 21, 24, 27, etc. Okay, all these are multiple of 3 also. Now I say that because we look at this word lowest common multiple. Okay, I first talk about the multiple. Now let's take the previous words and the words multiple all together, combined, okay? Common multiple. If I look at the list here for the multiple of 2 and 3, what are the common multiple? You can notice that 6 is there, 6 is also there, it's a common multiple. Okay, 12 is over here, and then 12 is there. Also, it is a common multiple because the 12 divides both 2 and 3. And then you notice also 18 is there and 18 there. So there can be so many common multiples. But now in the list of the common multiple, there must be one that must be the lowest common multiple. Lowest common multiple, I take this with them. Now, in this case, as you can see, the lowest common multiple is this number 6 here. It is the lowest common multiple. Okay, the LCM, then we can see the LCM. The LCM of 2 and 3 is just 6. Okay, but now let's dive into it, the questions now. Now, I have to erase all these. Question says, determine the lowest common multiple of 3 terms. Okay, 3 numbers. That's question 3, 9, 8, and 6. We won't really going to do the list as we did because it's going to be a lot of work to do, a lot of writing. Okay, there's a way to shorten these calculations by using what you call the 3 factors. Okay, how and what's this? Okay, the 3 factors will tell me the prime factor of each of these numbers, a prime factor of 9, of 8, and of 6. Let's do it. 9, for instance, if I want to try the prime factor of 9, okay, the prime factor of 9 will be like the smallest number except 1 that divide 9 is 3. Okay, the prime number that divide 9 is 3, and then the 9 divided by 3 is 3, and then 3 by 3 is 1, and then I can say the prime factor of 9 is just 3 times 3. Okay, next is 8. I'm gonna do the same. The prime factors of 8. 8 divided by what? 8 divided by 2. Okay, the smallest number or the prime number. The smallest prime number that divide 8 is 2, and then it's 4, and then by 2 it says 2, and then by 2 it's 1. So I can write here 2 times 2 times 2. Now also for 6, okay, for 6, the prime number that divides 6 is 2, and then it's going to be 3, and by 3 it's 1, and then that's going to be like 2 times 3. Now I need to find the LCM. From here I can find the LCM of 9, 8, sorry, 9, 8, and 6 is what? Okay, let's see. How can I do that? I prefer to label, okay, all the prime factors. So this is like 3, 1, 3, 2. Okay, this is like 2, 1 in this group. Okay, the first 2, the second 2, the third 2. In this other group also, it's the first 2, and that's the first 1. Now I'm going to get rid of those numbers that are labeled the same. Okay, like 3, 1 is already here. Okay, and then I cannot take this 3, 1 also because 3, 1 is already there. So I can cancel this 3, 1. I cancel that one out. Okay. That's just technique. I cancel this one. So I take this 3, 1. I cancel that 3, 1. 3, 2 is there, and then there is no other 3, 2. Not here, neither there. Okay. And then when I look at this 2, 1 first in the second group, 2, 1 is over here, and then 2, 1 is there also. Okay, so I can cancel this 2, 1. And then 2, 2 is here, there's no other 2, 2. And then 2, 3 is there, is also, okay, so now the prime factor will be 3. Okay, I want to take this 3 times 3 times 2 times 2 times 2. So 3 times 3 times 2 times 2 times 2, which is equal to, if you do the calculation, we're going to get 72. So the correct alternative here is 72. The prime factor of the lowest common multiple of 9, 8, and 6 is 72. Okay. Now, question 4. Here they say determine the LCM of the following 3 terms. We have like a squared bc, abc, and ab cubed. Okay. So over here, so to find the LCM, I just want to say LCM of all these terms will be like, I'm gonna look at the first term here, this first term, I'm gonna write a squared bc. Okay, you know, a squared is the same as a times a. Okay, so a times b times c. Okay, and then a b c is just a times b times c. And then that was ABC, and then AB cubed, AB cubed is just A times B cubed, meaning I'm gonna write B times B times B. So it's gonna be B times B times B. Now I will label all my factors, okay, because they're all factors. So I call this one in this group A1, this A2, the second 2 in the group, the first B in the group B1, the first C and the only C in the group C1. Now here the first A in the group is that one A1, that's B1, that's C1, and that's going to be A1, that's B1, B2, and B3. Now to get the LCM, I am going to get rid of the terms that repeat, okay? So if here I have A1 already, I cannot take A1 over here. I can cross this one out. I cannot take this A1 also, okay? Because I already have A1 there. And then I have A2 over here. Is there any A2 here? No, neither here. So I keep this A2. Okay, I'm gonna take B1 over here. B1 is here, B1 is there, B1 is there. So those B1 repeats, I wanna cancel them out. Cancel this, I cancel that one. C1 is over here, and then C1 is there. I'll cancel this C1. Okay, and then over here, this is B2, there's no other B2, and B3, there's not. So I'm gonna take these, this one and that one. So the LCM here will be LCM will be LCM will be then A times B times C. Okay, all this obviously, and then times B times B times B times B. So A times A makes A squared, and then okay, B here times B times B, okay, the common basis, so B to the power 3, and then times C. So the LCM will be A squared B cubed C, which is alternative 3. Okay, that's the LCM over the 3 terms. Now, the following question is question 5. The question says, determine the LCM of the following 3 terms. We have like 6x cubed, 8x squared, y squared, and 12xy. Okay, here we have the kind of mix because we have like digits and variables together. One way of solving this is to group all the numbers, okay, the digits, the constants. So we can find the factors of the LCM. So we can find the LCM of 6, 8, and 12, and we can also find the LCM of x cubed, okay, x squared, y squared, and xy to the power 5. Okay, we can separate them. We can put the digits or the numbers together and find the LCM of the numbers and LCM of the variables as well. Now, so now this will be I'm gonna write here LCM of 6, 8, 12. So the factors of 6 in 3 factors as we did previously. It's gonna be like by 2, it's 3, and then by 3, it's 1. So it's gonna be 2 times 3. And then 8 also, by 2, it's 4, by 2, it's 2, and by 2, it's 1. So the prime factors are 2 times 2 times 2. And then for the variables, we do have like x cubed, which is x times x, excuse me, and then x squared, y squared will be equal to x times x, okay, that's x squared, and then y squared is going to be y times y. And then for x, y to the power 5, you have like x, y to the 5. This will be x times y, 2, 3, 4, 5. Okay, so now I'm going to label these variables as I did in the previous question. I call this one x1, x2, x3 in this first group. Okay, in the second group is the first x, that the second x, that the first y, that the second y. In this group is the first x, first y, second y, third y, fourth y, fifth y. Now, I am going to cancel all these digits that repeat. I mean, all these variables that repeat. You see, I have like x1 here. I can take this x1. I can take this x1 also because it's already there. I have x2 here. I can take this one. I can't, yeah. And then I have x3 there. It's only x3, okay? Now, and then for the y, I have y1 over here. So I can take this y1. I have y2 there. I can take this y2. And then I can take this y3, this y4, and this y5. Therefore, and then over here also, for the digits or the numbers, like 2, 1, 1, 3, 1, 1, 2, and 3, okay? Oh, I didn't do the 12. Sorry, I'm gonna do 12 here. So by 2, it's 6, by 2, it's 3, by 3, it's 1, and then that's 2 times 2 times 3, and then they're like 1, 2, and 3. Now, if I need to find the LCM for 6, 8, and 12, you see, I have 2, 1 here. I can take this 2, 1. I can take this 2, 1. 3 is there. 3, 1 is there. It's the only 3, 1. And then 3, 2, 2, 2. I take this 2, 2. I can take this one. And then this is, so the LCM for these numbers, for the numbers would be 2 times 3 times 2 times 2 times 3, which is equal to 48. Okay, 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is 20. Okay, hold on. 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 3 is, am I doing correct? Okay, let's do it over again. Oh, no, it's because I called this one 3 by 12 while it was 3, 1. My apologies, this was 3, 1. Okay, so I can take this 3, 1 because it was already there. So there is no, this 3 doesn't exist. Okay, yes. So we have like 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is 24. So it's already 24. It's 24. So if maybe you want to consider alternative, if you have 24 there already, you know that you only have like these 2 correct alternative, okay? Because the digit, the number must start with 24. Now, for the variable x times x times x, there's no other x, so x cubed. So x cubed. And then the y, you have like 1, 2, 3, 4, 5, y to the power 5. Y to the power 5. So this is the correct alternative is alternative 2. Then the next question is question question 6. The question says that simplify the following expression as far as possible without using a calculator. So over here we have like 4 over 5, okay, minus 5 over 6, okay, plus a quarter. So if I need to simplify this without the calculator, I need to find the LCM, okay? LCM of these denominators here, 4, 5, 6. 4, 5, 6. To find the LCM, I want to do 4. Again, the factor 3 for 4, it's 2 by 2, 2, 1. It's 2 times 2. And 5 is already a prime number, so by 5, you get 1, and it's just 5. And then by with 6, it's going to be like 2, 3, and by 2, by 3, it's 1, so it's going to be 2 times 3. Now, if I label this is the first 2, that's the second 2, that's the first 5, the only 5. The first 2, the first 3. Then I will cancel those that repeat. I have like 2, 1 here. So, and then by 2, 1 there, I cancel this out. And then the LCM will be 2 times 2 is 4. 4 times 5 is 20. 20 times 3 is 60. Then I need to make this denominator equal to 60 because the LCM, when I say here, the LCM of 4, 5, and 6 is equal to 60. So now I would like to make the denominator, change the denominator to make it 60, equal to 60. How can I do? If I have 5, I must times 5 by a certain number to make 60, or times 5 by 12, okay? Because 5 times 12 is equal to 60. If you're unsure, you can check in the calculator. Let's see, if we do like 5 times 12, and this is equal to 60. Okay, so you times by 12. So whatever you do at the denominator, you do also at the numerator. So you times the denominator by 12, you must also times the numerator by 12. Over here, you times here. 6 times what equal to 60? This is the most obvious calculation. So times by 10, the most easy calculation by 12, by 10. Okay. We're going to times also the numerator by 10. And now 4 times what equal to 60. If you cannot see that it's times 15, the best way to do that is to do the other way around. You say 60 divide by 4 equal what? Equal to 15. Then you know, okay, I must times here by 15. So you times here by 15, you times here also by 15. Okay? Then you can use a calculator to find 4 times 12, which is 48 in the calculator. 5 times 12 is 60, okay, minus 5 times 10 is 50 over 6 times 10, okay, that's 60, plus 15 over 60. Now that the denominator is common, okay, we can just add the numerator. You know, when you work out fractions, you don't just say 4 minus 5 plus 1 like that. The denominator must be common, okay? Once you have a common denominator, then we can say 48 minus 50 plus 15, okay? So, you know, 48 minus 50 is -2, and -2 plus 15 is positive 13. So here it's going to be 13 over 60. Okay, so the correct answer is alternative 3. Thank you. Well, this is the third, page 3 of BNU1501, 2019 semester 2, assignment 2. I said page number 3, yes. Now, question 7 says, simplify the following expression as far as possible without using a calculator. All right, this expression consists of fractions with mixed operators like divide and times, okay? So when we divide or times fraction, we don't need to find the LCM. We don't need to find a common denominator, okay? We can just work them out as they are. So we have like 3 over 8 divide by 2 over 3 times by 4 over 5. So in this situation, you know, because we have a division here, we can change this operator to a times, okay? So it's going to be like 3 over 8. We change that to time. When we divide a fraction with another fraction like this, we change the operator divide by times, and then we reverse this fraction. Okay, please don't simplify 3 with 3. We're going to reverse. Okay, this fraction is going to be 3 over 2, and then times 4 over 5. Now we can simplify. Okay, we can simplify. If we if 8 here, we can simplify them across. We can simplify 8 with 4 because 4 gets into 8 twice, so we're left with 2 over here. And then what else? That's the only simplification we can do here so far. So we can do 3 times 3 is, okay, when we simplify, there it's 1 left. So we can do 3 times 3 times 1, which is 9, okay, over 2 times 2 times 5, which is 20. So the correct answer is 9 over 20. So it is alternative 1. Okay. Question 8. The question says simplify the following expression as far as possible without using a calculator. Still, it has a mixed operator, but we need to do that with regard the BODMAS rule or the BEDMAS rule. I don't know how you label them, but they mean the same thing. 3 over 7 plus this will be considered as one term. Okay, all this will be considered one term. So we have like a 3 over 7 plus all this. Okay, so this will be 3 over 7 plus, okay, we're going to put brackets here, 7 over 9 divide by 1 over 3. And then we're going to do as we did in the previous question. So it's going to be 3 over 7 plus 7 over 9. I want to keep this fraction like that, and I change the division to by times, and then reverse, okay, the other fraction. Okay, I'm going to reverse it, 1 over 3. It will become 3 over 1. Now we can simplify. Okay, 3 gets into 9 twice, so there will be 9, I mean 2 here, and then that 1. And then this will be just 3 over 7 plus, that makes 7 times 1 is 7. And then over here, I said 2, I meant to say 3, okay? 3 gets into 9 3 times. So it's going to be plus 3 times 1. You don't want to multiply a fraction. We multiply them horizontally. We multiply the numerator and we multiply the denominator. Okay, 7 times 1 is 7, and then 3 times 1 is 3. So we have like 7 over 3 plus 3 over 7. And then next you're going to do what? You're going to cross this, that, and that. Okay, listen to me. Don't ever do that. Be careful with the sign here. It's not a times, but it is a plus. So when you plus fractions, you need to make sure that the denominator are common. Okay, are common. So to find the common denominator is when we find the LCM of these two numbers, 7 and 3. Okay, we're gonna find the LCM of 7 and 3. 7 is a prime number, 3 is also a prime number, so we don't need to do the 3 factor. Okay, we just wanna do 7 times 3, which is 21. Now, 3 over 7 plus 7 over 3, it's 21. If I already have 7, if I have 7 already here, I need to get 21. I must times by 3. Times by 3, times by 3 there. Here, times by 7, times by 7 there. I don't do 3 factors because these numbers are already prime numbers. So we just times them, 7 times 3, 21. And then this will become 9 over 21 plus 49 over 21. Now that the denominator are common, okay, then I can add only the numerator, okay? Please, it must be equal to 9 plus 49 is equal to 58. Please don't say over 42. Okay, you don't plus the denominator, but you just add the numerator. Okay, so it's over 21. Over 21. Then when you look at this, we don't have this answer here. So if we did it wrong, no, we didn't do wrong. We're going to see sometimes answers are written in terms of what we call in mixed number. Okay, as you can see, some answers mixed number. Let's see if we can write this one mixed number as we did in assignment assignment 1. Or this assignment still, I don't remember. Okay, mixed numbers. So we see how many times 21 gets into 58. How many times? 21 plus 21 makes 42. 42 plus 21 makes 63. Oops, look, it's like that. 21. 21. Like 21. And then that's the first 21. The second 21 makes 42. 21 plus 21, 42. For the third time, it's 63, which is more than 58. Okay, so it can get into 58. 21 gets into 58 only 2 times. Okay, 2 times. Then 58 to 63. How much? From 58 to 63, it's just 5. So it's gonna be like 5 over 21. 5 over 21. Now let's look here. Here they say 16 over 21. I don't really think it is correct, but let's check in the calculator. If I do like 3 over 7, okay, plus 7 over 9, okay, and then divide by 1 over 3 equal to, you see, 58 over 21. And then if I press SD, okay, it doesn't give me it's 58 over 21. I think they didn't put here the correct alternative, or they meant to write here 5 over 21. I'm pretty sure this was supposed to be 5 over 21. Sometimes they do a few mistakes like that when they leave assignment, but the correct answer is 2 5 over 21. Okay. No, they're correct. I think I made mistake. No. They're correct because I said 53 to 58 to 50. That was the mistake. That was the mistake. Okay. It's rather for the second time it was 42. Now from 42 to 58 is 16. Yes. I look at 63. Sorry, I meant 42. Because you can get only 2 times. First time 21, second time 42. Now from 42 to 58, it's 16. So over here, it's 16 over 21. Yes, that's the correct answer. 16 over 21. No, correct. So there were no mistake here. The following question is question 9. Question 9 says that simplify the following expression as far as possible. Okay, again, because we're adding fractions, we need to find the LCM. We need to make the denominator common. To make the denominator common, it means we need to find the LCM of these denominators here, 5x squared and 5x. Now, we can first work out the LCM of the digits. You know, this is 4 and that 5 is a prime number, and then this is just 4. We can just do 5 times 4, which is 20. So we know for the digits we already have like 20. 20. Okay, and then x squared is like x times x, and then x is just, you know, it's just x there. The factors of x is just x. Now if I label this as I was doing 1 and 2 and then 1, I can't stack this again. So I left with x1 times x1, which is just x squared. So the LCM is like 20 x squared. So I have like, because I have 1 over 4x squared plus 2 over 5x, I need to make them equal to the LCM, as I said, is 20 and x squared. Okay, I need to make the denominator equal to 20x squared. Here, 4x squared. What I can do, I'll times here by 5. Okay, because 4 times 5 makes 20 and then x squared. Okay, I times the denominator by 5 there. I must also times the numerator by 5. There, I have 5x, but I need 20x squared. What I can do, I'll times by 4 here, because 5 times 4 would make 20. In this case, I'm gonna have 20x, but I need 20x squared. So I must times here by 4x, because 5 times 4 makes 20, x times x makes x squared, so 20x squared. I must also times the numerator by 4x, because whatever you do at the denominator, you must do at the numerator to keep your fraction even. So this will be 5 over 20x squared plus 8x over 20x squared. At the time that the denominator are common, okay, we can just add the numerator. We can write it like 5 plus 8x over 20x squared. So, which is alternative 3. That's the correct answer. So, the correct answer is alternative 3. Okay. And the last question in this page is question 4. And then the question says that write 2 over 9 as decimal number. Round your decimal digit without using a calculator. All right. Okay. This is what I want to do. I want to do 2 over 9. So it's going to be something like this. 2 there and then 9 there. So 9 cannot get into 2. So what can I do in this situation? Okay, I will add what I call the magic 0. Okay, I'm gonna put a 0 over here. It becomes 20, and then I'm gonna put a 0 there also, and then I put a comma there, a comma or a dot. Okay, depends on which one you use. Then I will say, okay, now 9 can get to 20. How many times? 9, 18, twice. Okay, I'm gonna say 2 over here, and then I'll do 2 times 9 is equal to 18. I'll write 18 over here, 18. Now 20 minus 18 is equal to 2. Okay, now I have another 2 here. 9 cannot get into 2. What can I do? Okay, I want to add another magic 0 over here. Now this time I won't put another comma also there on top, or put 0 and comma. No, I just leave it like that. Okay, 20. Now 9 gets into 20 how many times? 2 times. So right here, 2. And right there, 2. And then I do 2 times 9 is 18. 18 over here, 18 there. And then 20 minus 18, 20 minus 18 is again 2. Okay, they said I must do that write as a decimal around your decimal digit without using a calculator to 4 decimal places. Okay. On top here is the remember that the on top here is the quotient, the result of the division, and this is these are the dividend. Now I have like 2 decimal places. I need to continue because I say 4 decimal digits. Now I say again, I want to add another magic 0 there, and then 9 gets into 20 twice. So that's 2 there, and then 2 times 9. 2 times 9 is 18. So 18 again. okay? And then 20 minus 18, as you said, it's 2. And then 2 times 9, okay? And then 20 minus 18 is 2, and then I'll put another 0 there. 9 gets into 20 twice. So when I say here 2, this is the 4th decimal digit. Then I can stop here. Okay, I cannot stop here yet. I'll need to go to see what should be the 5th decimal value. But if you notice the pattern here, it's going to be 2 left over. So we can stop here by 0.2222. Okay, so the correct answer here is alternative 4. Thank you. Well, that's question 11, page 4. That says write 10^5/8 as a decimal number rounded to 3 decimal digits. Okay. Already, when you see like this mixed number 10^5/8, I know that we already know that this cannot be the correct alternative. Okay, that's start with 0 points. That cannot be the correct alternative. So I have left with these last 3 alternatives. Now, because 10 here stands for the integer part of the decimal number, here it's 0. The integer part is 0, but it cannot be this one. Okay, so this can be one of these 3. Now, I look at only the decimal part, then 5 divided by 8. What is 5/8 equal to? All right, then okay, 5/8. I can write here 5 this way. 5/8. If I need to find, I'll do 8 cannot get into 5. So what I can do here is I am going to add 0 on 5 here, and then put 0, comma there. Now 8 can get into 5. How many times? 8 gets into 5 like 6 times. Okay, you can check in the calculator. 50 divided by 8. 50 divided by 8, it's going to be 6, something, 6.25. Okay, so it gets into 56 times, and I write 6 over there. Then I do 6 times 8. This is equal to 48. Okay, 48. Now 50 minus 48 is equal to 2. Now what I can do then, I will because they say this is the first decimal place, the question says to 3 decimal place. Okay, so I'm going to add another 0 here, and then I won't put another 0 there, just 0 here, and I won't put any 0, no comma there, because we're already on the decimal part of the number. Now 8 gets into 20 twice, because 8 into 20 is like 8 and then 16, so twice. So over here I write 2. Okay, 2 times 8 is 16. 16 there. And then 20 minus 16 is equal to 4. Now, 2 decimal place, I need to get 3 decimal place. So 8 gets into, what I can do, 8 cannot get into 4. I must put 0 there. And then 8 gets into 40 5 times. I'm going to write 5 here. And then 5 times 8 is 40. And then that's going to be 0. So because it's 0, we cannot continue further, and then we have all the 3 decimal places. Now, the answer must be, because it was already 10 there, so it's going to be 10. It's like 10 plus 0.625, which is equal to 10.625. That's the correct answer. So it is alternative 3. That's the correct answer. Okay. Now we can do the following question. Is question, because of space, I'm going to raise this. Question 12. Question 12 says, write 2.525 as an ordinary fraction in its simplest form. Okay. we're going to cover these two here because this is the integer parts. Okay, we can see that's part of the mixed number. Mixed number has like integers and fractions. So 2 is the integer parts of the mixed number. I would consider only decimal parts. The decimal parts here will be it's like we have like 0.525, okay? And this, and if I want to write this as a fraction, it means I will count the place values like 1, 2, and 3. So I'm gonna write here 525 over 1000, okay? The number of the 0 after 1. So 3 times. Remove the commas 1, 2, 3. So I'm gonna say over 1000. Then I will look at how can I simplify this fraction. For me, for instance, I can divide here by 21. I mean by 25, the numerator, denominator. But in case you don't see it as straightforward as I do, try to go like, you see it ends with 5, so you can divide the numerator by 5. And then you divide also the denominator by 5. Remember the rules of simplifying numbers. Okay, when number ends with 0 or 5, it means it is divisible by 5. If we divide by 5 here, you will get 125. And then this 1000 divided by 5 is 200. Now you can divide further. You see 125, you can divide also by 5 again. And then you divide that also by 5. Okay, simplify. This will be again by 5, it's gonna be 25. And then by 5 there, it's gonna be 50. Okay, what am I saying? 40. Okay, now you can see divide by 5 there, and by 5 there, and then you get like 25 by 5 is 5, and then 40 by 5 is 8. So the decimal parts here can be written as 5 over 8. Therefore, we can write okay, 5 over 8, but I don't see any 5 over 8 here. Is there anything wrong with my calculations? 5, oh yes, 525 divided by 5 is not 125. Mistake, it's 105. Over here, it's 105. Let's check in the calculator. It's 105. Yes. 525 divided by 5. It is 105. So it's 105 here. That's where the mistake happened. So 105. So 105 divided by 5. It must be 25. This is equal to 35. Let's check. No, not 35, but 105 divided by 5. It's 21. Okay, so that's 21. 21, and then 21 we cannot divide by 5, so we stop there. Yes, it's 21 over 40. Therefore the correct answer is 2, the integer parts of the decimal, and then 21 over 40. So the correct answer is alternative 3. Now the following question is question 13. Okay, let's read the question. The question says that a blended fruit juice contains 3 main ingredients, namely mango juice, orange juice, and distilled water mixed in the ratio 4 to 5 to 1 respectively. How many liters of orange juice are needed to make 25 liters of this fruit juice? Okay. The ratio is from 4 to 5, 1. So 4 is for mango, because they say respectively. So they for mango, orange, and water, distilled water. M-O-R, mauve. Like that. Now, the way how can we get now? They say how many liters of orange juice, okay, are needed to make 25 liters of fruit juice. So now all the fruit juice together will be like 25 liters. Now in the fruit juice, remember, there's some parts are from coming from mango, some from orange juice, some from water. It is all 25. Let me draw a picture here so we can understand the question better. Let's say we have like a 25 liter of juice here. So now in here, we do have like, in here we have like mango juice. Mango, okay? Or maybe let me just do it over. We want something here. Okay, a container. Now over here we do have like mango juice. We put mango juice there, and then we also put in water, and then we also put in the orange juice and our water. Okay, now all together here, the mixture, okay, is 25 liters. Right, now they said the ratio is like 4 liters. For every 4 liters of mango, 5 liters of orange, and 1 liter of we put, for every 4 liters of mango, we put 5 liters of orange, and then 1 liter of still water. Now, the total here is going to be 25 liters. So how much did we put in orange juice in order to have like a total of 25 liters? So we're going to add all the ratio here. It's like 4 plus 5 plus 1, which is equal to 10, okay? We're going to do like 4 plus 5 plus 1, this is equal to 10. This is the total mixtures, the concentration. Then, because we have like a 25 liters here, we're going to do 25 over 10 times 5. Why 5? 5 because we did put 5 liters of orange juice. This will tell us how much orange juice was in the container here. If it was the mango juice, I'll times here by 4. If it's for water, I'll times by 1. Okay, if I need to find the concentration for orange juice only, okay, how much orange juice I put in there, it's going to be 25 over 10 multiplied by 5, which is equal to 12.5 liters of orange juice. Okay, so this is equal to, this is alternative 4. Okay, if you're unsure, you can check in the calculator. It's 25, it's going to be 12.5. You know, I divide here by 5, so we left with 2 here, and then 25 divided by 2 is 2.5. And then the following question says, Bag&For-You sells a washing machine for 1,320 rand, excluding the VAT, okay, without VAT. So we assume that the VAT is 14%. If you pay cash, the company offers 5% discount. How much will you save if you buy this washing machine in cash? Okay. Oops, sorry about that. All right. So we okay, they said 1,320 rand excluding VAT. So meaning when we buy stuff, it's gonna be VAT included. Okay, VAT is 14%. Okay, so 14% is 14% of this amount. Okay, so it means 14% right here. Cost with VAT will be 1,320 plus 14% of that money, okay, of 1320, okay, of 1,320. That's the VAT, with VAT included. So this will be like, you know, that words of in English is translated as time in mathematics. So it's 14%, okay? 14% is like 14 over 100, okay, times 1320. Okay, you can use a calculator here. We can just do, you can, in the calculator, you can do 1320 plus 14% is same as 0.14, okay? Times 1320, because it is 14% of the initial price. So this is equal to, if the calculator tells you this, you must press SD. Okay, this is equal to 1504.8. This is the cost of the washing machine, VAT included. Okay, now the question says that the company offers 5% discounts. Okay, so 5% discount. What is 5% of this amount? Is just, you know, we're just gonna say multiply this answer, multiply by 0.05. This is 5% of this is 5% of this amount. So actually we save 75.24 because the total cost was this. Okay, now the company offers you 5%, so you save 5%, so you're going to get 75.24. So say 5% of 1504.8 equal to 75.24. So it is actually alternative 1. And then page 5. Okay, I'm gonna put it now. Yeah, it's question 15, page 5. The question says that a school has 880 pupils. If the ratio of the numbers of boys to girls is 7:4 respectively, how many more girls should be needed? Should need to enroll if the school authorities wants the ratio of number of boys to number of girls to be 1:1. Okay. There's a total of 880 pupils. Okay, pupils, and then the ratio is 7:4. Okay, boys, ratios of boys to girls is 7:4. Now, if we need to find the total number of girls in school, okay, maybe yes. Let's first find the total number of boys in school and numbers of girls in school. We're going to do, because the ratio is 7:4, we can do 7 plus 4. Okay, 7 plus 4, which is equal to 11. Now we will do like 880 divide by 11. And then that, if you do that in the calculator, we're gonna get 80. Okay, 80. Let's check. 880 divide by 11, this is equal to 80, correct. Now, to find out the number of boys in the school, we're going to do 80, okay, this 80 here, times by 7, because the ratio is 7:4. 7 for boys, okay, 7 for boys, and 4 for girls. So we're going to do 80 times 7. So we understand by that there are 560 boys in the school, and then ratio for girls we times here by 4, and then you see there, no, 80 times 4 would be 320. So 320. You can check 320 plus 560. That must be equal to 880. Correct. So now to get now the number of girls, we must do if the authority want to enroll more girls in order to have like a ratio of 1 to 1 or 1:1, okay, we must do 560 minus, okay, we must do like 560 minus 320, which is equal to 240. So there must be 240. If they enroll 240 girls, okay, then the ratio will be 1 to 1. So therefore, the correct answer is alternative 3 to 40. Thank you.